Hello everyone, welcome back to the SDL2 on Xcode series. In this tutorial project, we are going to build the classic snake game on Xcode using C and SDL2. This is episode 14. In this episode, we are going to build the loading scene for our snake game. To be honest, we don't really need a loading scene here because our game is so small that we don't have too many things to load. But it is a good idea to know how to make one, in case we need it in a bigger game project. The rough idea of a loading scene here is to break the loading task into smaller one. For example, I can break one task into many steps, and within one frame, we are going to load as many steps as we can. After we do the loading task or loading steps within one frame, we'll displace the loading progress to the user. And that is the rough idea for the loading scene. Let's take a look at the structure here. We have a structure called task type. And this is a structure to capture one group of tasks that can be separated into multiple steps. In one update, we're going to go update or advance one step. If the step is the same as the total step, then this task is done, and that is the structure for the task. Let's see what other field we have for the task. First of all, here we have a next field. This field here is to make our structure into a list so that we can put multiple tasks together. And we have a name for our task, some methods associated to our task. Here we have init function to initialize the task, a clear function to clean up the memory, and finally the update function that is actually to advance one step. Here there are two variables to control the total numbers of steps within one task and the current step. Finally, we have an extra argument here. So that is all the fields we have for a task. And you can see that we define this field using a macro. In order to define a task structure, we just need to put the task head at the beginning of our structure. And if you use a task macro here, then you can treat this structure as a task and then use these three functions. And these three functions, as you can imagine, basically a wrap-around methods in here. For example, if you call the init function on a task, it basically will do the following. It will call task and then methods and then init on itself, and that basically what this task init function does. We have seen this before actually within the scene manager. We know that in the definition of a scene, we need to have 5 functions: the init function, the clear function, the handle event function, render function, and finally the update function. Right? We use the same idea to define a C class or a class within C. And finally, we have another method called task append that basically treat a task as a node within a list and then append a node into a list. Then the function will return the new list, and that is what we do for in this task.h. And the implementation is simple, so I'm not going to go over it. So you can see that basically the task init function is the core of this function, as I said before, but we need to do some error checking and then we need to do some logging, and that's it. Now, let's see the result of our loading scene. So when we run the game, the first thing we see is now the loading scene, and you can see that there's the progress bar here that indicating the loading progress of our game. After the loading scene is done, we then switch to the menu scene. So let me stop this and see how we actually implement the loading scene. If we go to the definition of the loading scene, you can see that it is basically the same as what the other scenes we have done. Within this loading.c file, we have our local scene structure, and in here there are some extra arguments. For example, we have step and total steps. This total steps represent the total number of steps for all tasks within our game. We have a background for our game loading scene. We have the progress bar, the task list, and also the current task. Now, let's see how we initialize it. Since the loading scene is to load all the resources, and because of that, the resource that we use for this loading scene has to be loaded in other way. In this case, we just load it directly here. You can see that I use the image load texture from the SDL2 image extension library and load our background directly here. If we cannot load the background correctly, then we will return false, indicating that we cannot initialize the loading scene correctly. And then we compute the position of the progress bar. And finally, we will get some information about the task. For example, we will get all the tasks and then put it into the task list here using the task append function. And then we are going to initialize all the tasks and get the total number of the steps for all tasks. To do so, we are going to enumerate all the tasks and initialize each task. And then we will get the accumulate the total steps for each task into this variable Syn total steps. We have to initialize the task before we accumulate the total step. The reason for that is we might need to initialize the total step within this function. So that is the reason why we call the total init function first and then accumulate the total step into our scene structure. So that is the initialization code. The cleanup code is not too bad. We just need to clean up the background structure and then call the clear function for each task, and that will manage the memory for each task. Next, for the render function, there are basically two parts. The background, which is directly rendered on the scene or on the screen. For the progress bar, there are two parts as well. The first part is the outline of the rectangle. So that is done here. You can see that I use some function from the SDL2 GFX extension library. And then the next part is to draw the filled rectangle using the computed width here. You can see that this computed width depends on the current step and also the total step. And that will give us the filled rectangle if I use this command here, rounded box color. So that is the render part. The difficulty is in the update function. So I will leave this at the end. So let's skip to the final part. So the handle event function handle only one event, the SDL2 event. The reason why we are going to handle this event here is that we are not going to use the app delegate for the loading scene, because the loading scene is also responsible for initializing the app delegate. That is the reason why we have to handle the SDL2 event ourselves in this loading scene. Now let's come back to the last piece, the update function. So first of all, we check that whether we have undone task. If there's no undone task, that means we finish loading and then we will switch to the app delegate. And you can see that here, only if all the tasks are done, we will go to the app delegate. And that is the reason why we cannot use the app delegate to handle the default SDL quit event and we have to handle it here ourselves. And then for each frame, for each update, we're going to compute the total amount of time we have for each frame by doing this function here. And the reason why I have +1 here is to avoid being 0. Imagine that if I get the FPS to be extremely large, say 2000, then 1000 over 2000 as an integer will be 0. Then we will come into problem here that we can't even load one step. But by adding 1 here, that will guarantee we have at least some time to load one step. Now we do some change to this engine get FPS as well. We'll talk about this later. But for now, let's just say that this variable time left basically compute the amount of time we have in one frame. And then within this frame, we are going to do as many steps as we can. And to do so, we are going to use the task update function to advance one step. So that is the advance one step. If the task is done, basically means that if the current step is the same as the total step for this particular task, then we are going to move to the next task here. So this delay function is for us to see the loading scene clearly. Without this one, we won't see the loading scene. Let's check. With this line commented out, you will see that the loading scene will go away quickly, and that is because we don't have that many resources within our game. That is the reason why I put the delay function here for us to see the effect of the loading scene. In our end product, we should not have something like this in our code. But for now, let me keep it here. The last 3 lines is to compute the time we use for loading this particular step, and then we will decrease the time left by this amounts of time we use in this particular step. So that is the loading part. Now, within our game, we basically have only 2 groups of tasks. One is for the resources, and then the other one is for the scene. You can see that we have 2 kinds of tasks here. We're going to discuss these 2 separately. But before that, let me give you an outline. The resource task basically load all kinds of resources, and for the Syn task, it basically initialize all the scene required for our game. For example, the menu scene, the game scene, and also the app delegate as well, because the app delegate is also a scene. Now let's look at these 2 group of tasks. Now let's go to the resource. Here you can see that we have a new exposed function called resource task, and that will return a list of resource tasks for our game. The implementation is not too hard. It's basically a small modification of our original code. You can see that we define a new new task structure called resource task, and you can see here that we use the task hand to make this structure into a task. And other than that, we have 2 more fields, the items, and also a manager corresponding to this resource. We have a unified resource task init function. Basically, depending on what kind of items we have, we will get the corresponding manager here. You can see that we have 4 kinds of items that we are going to load within this game that will correspond to 4 different kinds of managers. Next, we are going to initialize the total step by counting the number of items in these task items. And finally, we are going to resize the task manager by this total number of items within this task. Now, let's see. Next, we're going to do some update function. For the update function, we need to do a specified update function for the texture, and we have a generic update function for other resources. To do the texture task update, we basically go back to here. We basically modify this function and then make it into a function that only load one item. You can see that basically we will make this loop into one step. That means we just need to copy and paste this part and do some modification. And that is exactly what I did here. If you take a careful look at this, you will see that this part is exactly within the for loop I just highlighted above. And then we have some other code here to update our task. And then based on this init function and the update function, we are going to initialize the texture task. This texture task, we have methods defined here. The init function is defined as above by the resource task init function. We don't need to clean up any memory in this case. And finally, the update function is given by the texture task update here. So that's how we define the texture task. The same are done for 3 other tasks. First of all, we define a generic text update function. And this update function is basically a, I think here, basically just a copy of this part. Or to be more precise, basically this command. So the generic update is to call this function on the correct manager and the correct item. Let's come back to here and see our generic update. You can see that our generic update is exactly calling this function manager load on the manager associated to this task and the current item to load. After we load this item, we are going to update our task. And that is the generic update. Once we have this generic update, we are going to define the generic methods for our 3 other tasks. We have the resource init function. Again, we don't need to clean up any memory. And finally, we have a generic task update function. And for the phone task, music task, and also the chunk task, they have the same generic methods. The only difference in this case is the items. You can see that here we have the phone items, here we have music items, and finally we have the chunk items here. All other fields will be correctly initialized based on this resource task init function. For example, the manager, for example, the total step. Finally, let's look at how we implement this expose function resource task. Remember that this will return a list of all the resource tasks. So we are going to create an empty list at the beginning and then append to this empty list all the tasks. You can see that these are all the tasks we are going to do within this game. And finally, we return the list of the resource task list. And that's it for the resource tasks. And then next, we are going to also look at the Syn Task. The Syn Task basically is to initialize all the scenes we need for our game. Let's take a look. In this header file, we just expose this function to return a list of Syn tasks. Next, the implementation of this one is a little bit interesting. Let's take a look. We are going to define some clear function and update function. We don't need to have the init function for our Syn task in this case. Let's take a look at the clear function and the update function. For the clear function, we are going to call the Syn clear function to this task extra. And this task extra is actually our extra argument, in this case, to store the scenes associated to this task. And then you can see that here I use the free function to free the task as well. You are going to see why I'm going to use this free here. Next, the update function is simple. For the Syn task, we only need to initialize the scene using this function, and that's it. And To get the methods, we're going to put the init function to be null. That means we don't need to do any initialization. We have the clear function and update function defined above here. Now we are going to have something new. This function, Syn new task, is actually a function that will create a new Syn task based on the input Syn. To do so, we are going to allocate a new structure, task structure called task. And if we can get this new task, we are going to initialize the next pointer to null. That means currently it is not pointing to next task. We are going to set the task name to be the Syn name as well. And for this Syn task, they share the same Syn task methods here. For the total step, we only have one because we only do the initialization. And you can see here that the key point is to keep the associated Syn to this task extra argument. And that will initialize the Syn task, and then we return it, and that's it. Because we allocate the new memory for the task, and that is the reason why we need to free the memory in this task clear function. Now let's see how we return a list of Syn tasks. The idea is the same as the resource task. We are going to get an empty list at the very beginning, and then append to this list all sorts of Syn tasks. You can see here that we create the Syn task for the menu Syn here. The same thing is done for the game Syn, game over Syn, game pause Syns, and the app delegate. And that will give us a list of Syn tasks. And that's how we manage the Syn initialization. So with these two functions, we're going to get all the Syn tasks in here for our loading Syn. So that is basically the implementation of our loading Syn. Let's talk about some issue. Let's come to here. Go to the update function. The last piece that I would like to talk about is this function. In order to compute the amount of time within one frame, we're going to use this engine get FPS. But if you remember or recall from what we did in our engine, this just returns the frame per second we set. We can set the frame per second to 2,000, 10,000, or whatever we like. But that is not the correct frame per second for our game. In order to correctly address the frame per second variable, we need to do more things within our game loop. You can see that we do some changing here. We are going to keep track of two variables called frames and second. This second just means 1,000 milliseconds. So, and after we finish one frame here, we increase the frame counter by 1. And then we are going to compute the time for this frame and add it to the second. If this is bigger than or equal to 1,000, that means we have 1 second already, and then that would be our rough estimation of the frame per second variable. So we put this frame counter into this new variable engine.trueFPS, and then we will set the frame counter and the time counter as well. Now, we're in the getFPS function, we're not going to return the engine.fps, but now return the engine.trueFPS. So that is some adjustment we did in order to get a more accurate frame per second in our game. So that's it for our loading Syn. Thank you for watching.